Hello everyone, welcome back to the power system, class 15 again. In this part, we're going to talk about power system transmission line capability. So how much power you can send through the transmission line depends on two parameters, thermal loading limit and the stability limit. So thermal loading limit is because of the current, how much current you're basically drawing through the transmission line. If you demand too much real power and too much current will go through the transmission line, that resulting heating of the conductor and then resulting in the sag. Sometimes those sags could be irreversible. Okay, so as thermal is 3 times voltage rated voltage, and how much current going through it. So more current will produce more heat will produce more sagging. All right. So and also stability limit, as we talked before, you don't want to go over 90. If you go over 90, your mechanical power input would be higher than your electrical power output. So you have a imbalance there, then more mechanical power coming in, and you're spinning the generator more and more, then it will go out of sync. So you don't ever want to go over this 90 degree for. So this is your a loading angle over here. This is the max power. This is the 90 degree at this point over here, right? So you have to operate over here somewhere, say P max. So you don't want to deliver max power at all. So you have to operate somewhere here around midpoint. So you have room to on both sides to swing, right? So that's why 30 to 45 is a good place to operate your power system, all right, for the loading angle. And how much power you can also go to the line and to the load can be converted into SIL. So this is the X prime for the lossless line. So your power delivery equation we have learned from the previous classes is this. So this is a line to line sending end, line to line receiving end, divided by impedance of the line times sine delta. Delta is the loading angle, same one right here. All right. So now if I modify this equation a little bit and divided both voltage by V rated over here, and also put them on the top here to cancel it out, and GC over here can come over here, and then sine delta over sine beta L can stay over here, right? So it's a modification, same equation we modified with to bring them into per unit values in here. So that's the same equation over here. So this one becomes per unit, this one becomes per unit, right? So both are per unit right here. And if you remember from the previous class, this has become SIL. So that's right here. And sine delta over sine beta L. So you can now see the power transfer in terms of per unit voltage and as well as SIL, right? So if this factor is 3 times than SIL, that means you're basically transmitting 3 times of SIL power. If 5 is transmitting 5 times of SIL power. Normally, actual power transmission is like 4, 5, 6, 7 times of SIL. To see that in action, we're gonna do this problem in the class to show you what is SIL, what is the real power transfer, and how to manage it. Okay, we're gonna do it in the class. So then we're gonna get next class. We're gonna get into the compensation.